Okay, so I was asked to make a video of what we've been going over, so I'm going to use our notes from 7th period to do this. I want you to understand it's real important to learn these vocabulary words and learn concepts, and be sure and ask me questions in class or shoot me an email if you have any misconceptions or questions. Now we're learning about a mole. A mole is like a pear. So if we have the word pear, we know that that equals 2. We know that a dozen is going to equal 12. So here we have the word mole in chemistry. This is a standard unit. So it's our standard unit for the amount of a substance. One of the concepts that we need to know is the molar mass. This is how many grams are in 1 mole of a substance. It can be any substance. We're going to use the periodic table to find out the molar mass of different elements and compounds. So how to calculate our molar mass? We're going to determine how many atoms of each element are present. We're going to look at the subscripts. If there are parentheses, we're going to multiply the number outside times the number inside. We're going to find the mass of each element on the periodic table. So let's remember that our atomic mass is here. Okay, so we're going to round to 2 decimal places. 2 decimal places. That's the pennies place. This, okay? So for instance, in silicon, it will be 28.09 because 6 is greater than 5, and so we're going to round it up. Our units will be grams per mole, or you can use them as, because it's grams per 1 mole, or we can just drop the 1 mole and write grams. Okay. So we're going to find that mass on the periodic table. Remember, if the second number to round is 5 or up, we round the next number up. If it's 4 or less, we keep it the same. So for magnesium, we look on the periodic table and we see that magnesium is 24.305. So we underline that pennies place, that hundreds place. We look to the right and we see that this number is 5 or greater, so this number rounds up, so 24.31. Go ahead and practice this if you've never done it, and just underline, draw your arrow to the next. So this one will round up 487. Calcium is 40.078. Okay, looking at the 7. And so this will round to 40.8. Now oxygen is 15.999. So we're going to look to the 9. We round this up, it becomes 10. Carrier 1, 10. Carrier 1, 16. Okay? So we multiply the mass of the element times how many atoms of the element are present. We add those masses together, and the unit for molar mass is going to be grams, or like I said, the grams per mole. So barium chloride. We have 1 barium. We look on the periodic table and we find that barium is 137.33. Chlorine, there's 2 of them, and 35.45. We add them together after multiplying and get 208.23. The next example was aluminum sulfate. We're going to have to multiply the subscript. So we have 2 aluminums, each one 26.98. We have 3 sulfurs, because 3 times 1 is 3, times 32.07. Oxygen, there's 12 times 16, and we get a molar mass of 342.17 grams. Now, iron 3 acetate. Remember, we're going to unswap and drop on this one. So iron is 1 times 55.85 because there's 1 of them. Carbon, there's 3 times 2 is 6, and it's 12.01. Hydrogen, there's 9 times 1.01, and oxygen, there are 6. Add them all up together, and we get 233.0. Now, we learned molar mass. Now let's use that to find the percent composition. Remember, percent composition is part over the whole. Times 100 to make it into a percent, to move that decimal from a percent. Percent composition is the percent by mass of each element of a compound. You do need to know that definition. To calculate the percent of an element in a compound, the part over the whole times 100, which means the element over the compound times 100. We have to make sure we get that total mass of the element. Forget this part right here, ignore that. In my class, every time we circle our unknown, we underline our given. So what is the percent of chlorine and aluminum chlorate? There's 1 aluminum, there's 3 chlorines, and there's 9 oxygens. We find the molar mass of the aluminum chlorate as 277.33 grams. So then we're going to look for chlorine. So chlorine is here. Chlorine over aluminum chlorate. So 106.35 divided by 277.33. Put that in the calculator times 100, and we get 38.35%. So for homework, we did iron 3 silicate. Find the percent of iron in iron 3 silicate. Find the percent of silicon in iron 3 silicate. And find the percent of oxygen. So we found our molar mass of the compound, divided each of the individual by the total molar mass, and we got 38.86% for iron, 24.79% for silicon, and 42.36% for oxygen. Add these all three up together and we should get 100%. Then we did the same thing for glucose. So that was our percent composition. If you have any questions, please make sure that you email me or ask in class.